In the last video, I got the X and the Y axis moving. I got the end stops hooked up and wired. So the machine was auto squaring on both of those axes, and I didn't get the Z axis complete, but I have got that completed now. So let me zoom in here and show you exactly how I got this accomplished. And that was by going to Thingiverse and looking to see if someone else had solved this problem before, and they kind of sort of did. It didn't really work for me, but I made some improvements to it and I've got a working solution. So what I did is I went and I downloaded this little motor clamp, this clamp that goes around the motor, and then it has this little piece here attached to it. And the original idea was to hook the end of the cable chain to here and then let it just kind of hang freely in the air, which that was the part that didn't work for me. So the idea was that this cable chain would just hang in the air, and then as this moved back and forth, the rigidity of the cable chain would hold it in place. And that kind of sort of worked. The problem was that as it got closer to the zero, this direction, got closer to the zero coordinate, this wanted to sag down and it would rub across the top of these roller assemblies right here. And then the other problem was when it moved away from the zero coordinate here and then wanted to come back, it would sometimes get jammed up. It would sag down and it would get jammed up inside of the roller assembly here. So I tried 3D printing the chain like I did on the X and the Y axis, but it just didn't work as well. So I ordered some off of Amazon, and I've got a link to that in the description, and that worked better. It didn't jam up here on the front, but it did want to sag and drag on these assemblies. So what I did to correct that problem was this. I printed another one of these motor clamps and put it on the opposite side of the X-axis, and then put a piece of plywood that I had and just trimmed it to the same width as this little mount here, and then ran it across the length of this axis, and then on each end I just drilled a hole and ran a nut and a bolt through here, and that holds this in place, and that gives the chain, this cable chain, a rigid surface to ride against, and it also clears the rollers. And I don't know how well this is going to show up on camera, but you can see here's the chain, here's that little piece of plywood, and then there's probably about 1 millimeter or 2 clearance right here between the plywood and this roller assembly, which is more than enough. It doesn't rub, and so far it hasn't had any issues. So now I'm just going to give it a quick test. I'm going to tell the machine to lower the Z-axis. We're going to go about 20 millimeters here. I don't even know if that's showing up on camera. So the test worked. I told it to go down 20 millimeters, and it did go down. And so now I'm going to raise it back up. And it is going the correct direction, so I know that I have my motor wired correctly. So now I'm ready to do what is called the crown test. So the crown test, this is something that is on the Mostly Printed CNC webpage. I've got a link to that in the description. And what it is, it's basically, it's a file, and it's just something to get familiar with the machine and the software. And what you're supposed to do is draw a crown on a piece of paper instead of just going straight at it and hooking a spindle or a router up here, finding out you don't have something set up right, or you're not really familiar with the software as you thought you were, and then you tear something up. So what I've done is I've downloaded the file, I've created the G-code, and I've 3D printed this pin holder. So what I'm going to do is I'm just going to draw a picture of a crown, hence the crown test, and that will tell me if I've got the machine all hooked up correctly, if it's skipping steps, if the belts are slipping, if there's any problem with it. This will hopefully tell me before I hook up something more expensive like a router and some bits and some plywood and find out that it's not working. So I'm going to start the crown test right now. Okay, so it looks like the crown test was a success. Everything looks good on here. It doesn't look like there's any skipped steps on the motor or any belt slipping. So now I'm going to move on and see just how accurate the machine is. Okay, so I've got my dial indicator all set up, and I'm going to move this axis this direction. I'm going to tell it to go 10 millimeters, and I know from doing some calculating that 10 millimeters roughly equates to about 393 thousandths. So here we go, we're going to go 10 millimeters, and it looks like it ran about 391 thousandths. So let's back it off, see if it goes back to 0, and it does. So it is consistently about 2 thousandths off. So let me zoom in here so you guys can see this. So here it is all zeroed out, and about 391 thousandths. So I'm going to do some configuring in the firmware here, or on the LCD screen, and I'm going to change the steps per millimeter. I'm going to see if I can't dial this in a little bit better. Okay, so I've gone in and I have changed the settings on the Rambo board, and I have changed the steps per millimeter from 100.0 to 100.8. So that seems to have done the trick. So let me show you guys here. We got 393 thousandths, and then it goes back to 0. So we've got some good repeatability here. So I think I've got this axis dialed in. So I decided to go ahead and check the x-axis, and it was off by the same amount as well. It was only going 393 thousandths, but I made the same change, and as you can see here, the same change in steps per millimeter gives me the same result as the y-axis. So I think I've got the x and the y dialed in. So the next step would be to hook up a router or a spindle right here to the z-axis and actually do some cutting with the machine. But I can't do that right now because I'm waiting for my spindle to arrive in the mail. So while I'm waiting for more parts to arrive, I'm going to answer a question that was asked by a viewer named Sean Whiteley, and I hope I'm pronouncing his name correctly, but he wanted to know how I keep this wire loom from fraying out like this. All right, so when I cut a piece of this wire loom like so, the first thing I like to do to keep it from fraying out is just stick it into an open flame. Anything would work, a lighter or a candle, and you just want to put it in there long enough to melt the end like so. And then while it's still hot, I like to just kind of mash down on it on a hard surface, and then that flares the end out. And now you can see that I can rub this all day long and move it around, and the ends are not going to fray out. So here's the other end that I have not put into the flame, and you can see how easy it is to undo that braid, and it starts to flare out. So now I've got links to all of the files, the supplies, and the tools that I've used in this project. Those links are in the description of the video. And if you like the video, please give me that big thumbs up. And if you haven't already, ring that bell so you're notified of upcoming Making Stuff videos. And thanks for watching.